Hi there, and welcome to Hyundai Power Products. My name is Adrian, and today we're going to be looking at this HYM530SPE Lawnmower, and specifically the electrical system. So there's nothing more frustrating than going to start your lawnmower, pulling on the OPC handle, pushing that start button, and nothing happens. So what we're going to do is look at what possibly could be wrong. Now, the electrical system itself comprises of a battery charger and battery, 3 switches which we shall go through, and a starter motor. So it's not a complicated system, and we're going to look at each individual component one by one and see if we can find a fault and why it doesn't start. So at the heart of the system is the lawnmower's battery. Now, this lawnmower does not charge the battery when it's running. So after several times you cut the lawn, you may well need to charge the battery, and obviously we do supply a battery charger. So we'll just have a quick look at the battery charger and the battery to make sure everything's operating correctly before we move on. So I've just plugged the charger in, and as you can see, I've got a green light there in the off position that shows that there's no battery connected. So that would be normal, so I know the fuse isn't gone in the plug. If you get no lights at all, then there's a possibility that the fuse has gone in the plug. But we've got that green light on there. So I'll plug the battery in now. Connect the battery up. There we are, and I don't know whether you can see it. I'll bring it up into line of sight, and you can see we've got a red light on there now, which tells us that the battery needs charging. It's not fully charged. So we'll leave the battery to charge until it's fully charged. So the battery's been on charge for enough time now, and as you can see, the green light has come on to show that the battery is fully charged. And as you can see, if I push the button here, it shows all 4 LEDs are lit and the battery is fully charged. If you've left the battery on charge for 5 hours, shall we say, and you don't get all of the lights lit up, then it's possible that there's a fault with the battery or with the charger itself. So with a fully charged battery, we're ready to go. So I've got a fully charged battery. I've inserted it into the battery box, made sure that it's pushed in securely, pulled my OPC handle, pushed my start button, and still nothing happens. So let's move on and diagnose what the problem is. So as I mentioned earlier, we have 3 switches which all have to be made for the starter motor to engage. The first one is on the other end of the cable on the OPC, which is at the engine end. The second one would be the start button itself, so that's 2 switches. And the third one, we'll bring you across. And of course the third one here, it's actually a solenoid, but for the purposes of this, we'll call it a switch. So when the top 2 switches are pulled, this switch or solenoid should actuate, which engages the starter motor and starts the machine. So that's the third switch. And of course the starter motor is here. So other than a flat battery, by far the most common problem is the adjustment of the OPC cable. If this cable is out of adjustment, it won't make the switch down here at the engine end. So what I'm going to do is I'm going to take the covers off the top of the engine. You won't need to do this to adjust it, but I'm going to take the covers off so you can see the little switch that I'm referring to. I've just loosened the adjuster off, but as you can see here, this red unit is the third switch of the 3. And for the electric start to work and the mower to work, this switch has to be in the up position. So when I pull the OPC lever, as you can see, because I've put it out of adjustment, it won't hit the switch. And another thing you'll see with this, and I'll bring you up to the handlebars, so the OPC cable itself has got quite a bit of slop in it. And as you can see, it's not pulling it to its full degree. And I've got free play in this handle, which I shouldn't have. So we'll go down to the bottom and adjust it back to the correct position. So it's a very simple process. Say for instance that nut was tight against the front there. I'd undo that front nut, pull the cable back until I feel some resistance about there, and then do up the rear nut. Okay, so that's a starting point. So I'll go back up to the handle now and see how much free play we've got. So back up to the handle end. There's no slop in this handle, and it still pushes all the way. I'll bring you back down the bottom and you can see the switch actuating. So here's the little lever on the switch. So this lever here on the engine is the engine brake. So when I pull on the OPC, you'll probably hear the switch click. Yeah. We can hear it clicking. So that's correctly set. So now that I know I'm in the correct position, I'll just tighten up those nuts to make sure it doesn't come loose. There we are. That's firm and secure. Last check of the switch. Everything's working correctly. So there's a good possibility that now that I've adjusted the OPC, that the electrical system will now work. If it doesn't work, we shall move on. So I want to electrically test the push button. So the first thing I can see with the battery in is that the light is lighting up. You can see the green there on the push button. So I know that I am getting a positive and negative supply from the battery to the push button. If that light is not coming on, then we need to investigate the wiring. We shall go into that in a moment. But yes, the green light is coming on. Obviously nothing's happening, but if that green light comes on, we know that the button is okay. It's working, because it only comes on when you push the button, so that says the switch is working. If the light isn't coming on, we'll have a little look at the wiring from the underside. So I've just disconnected the little plug and socket. You can see there's a white one here. That goes down to the engine. There's 3 wires in it. And the switch has 3 wires into it. So we know the switch is working in this case, but if the green light isn't coming on, we need to check we're getting power to the switch. So if we look at this plug, we'll see there's a blue, a red, and a black wire. We should be getting the battery voltage across the red and the black. So we'll check for that with our meter. So I've got a little test meter here. I've had for numerous years. I've set it on a DC voltage. And I'm going to probe. Let me bring you back up. Yeah, I'm going to probe the black in the black, the red in the red. Have a quick look at my meter. 12.6 volts. Okay, so I know I'm getting a positive supply to here, so I should be getting it to here. So if I'm not getting any voltage across that red and black wire, that's where I know it's not the switch's fault it's not lighting up, it's because it's not getting any voltage. Okay, so I'll connect it back up and we'll see why that might be. So you'll see where the loom enters the engine here. You've got this soft sleeving which is crimped in with a cable tie, so I'll just pull that out of the way, and this reveals quite a lot. We've got a couple of connectors here. Now sometimes these connectors can come undone. That can cause the problem, especially this one here. If this comes undone, which can happen during handling, when you're assembling the mower, this plug can come undone, and so can this major plug here, but it's far more rare. So this being the main plug. So what we've got here is a black and red, which come down from the battery. So these are permanently 12 volts across the two. So we can just check that we're getting 12 volts down at this point. I'll just put my meter there. I don't know whether it's in screen. Yeah, just about. And I'll just check again across the black and across the red. 12.6 volts. So I know the battery voltage is getting down to here. Now, when I push the button, I should be getting 12 volts to this blue wire. So if I go across there, in fact I can probably backfeed there, across there, plug that into there. Now I need to push the button. So I'm coming across the blue and the black, and I should read 12 volts when I push the button. So let's just see if I can get somewhere near. I think I'm going to have to move the camera. Okay, so if I push the button now, 12.57. That's operating correctly. It pretty much proves that my switch is working correctly, because I am getting a feed down the blue. If I wasn't getting it, the 12 volt reading, I know I'm getting negative here because I'm reading 12 volts across these two, then it would tell me that the switch is faulty because I'm not getting a 12 volt positive feed down the blue. So that would tell me the switch is faulty at the top. As it happens in this case, it's fine. Now a bit further up this plastic tubing, here, there's a connector between the black and the red. There's a small red wire that goes back up the loom and a small black wire which goes back up the loom. These are the two wires that feed the switch along with the blue. So it's possible that we've got a bad connection inside here somewhere which would need investigating if we weren't getting all these correct readings here. So we're going to move forward. We have 12 volt supply on black and red here. I'll just reconnect that. And when I push the switch, I'm getting a 12 volt supply down this blue wire, which then becomes brown on the other side of the switch. I'll just push that sleeving back in place temporarily. Okay. So all that's connected correctly. So what we know is that everything is operating correctly as far as this point here. So if now we pull the OPC, we push the start button and nothing happens, there are two possibilities. The starter motor itself or the solenoid could be faulty. So let's diagnose that. So what I'm going to do is, this is the main positive coming to the solenoid, which is a switch, remember? And this black lead is the other side of the switch, which supplies the 12 volt positive to the starter motor. The starter motor gets its 12 volt negative direct from the ground of the machine, and this black wire coming from the battery connects directly to ground. Okay, if I pull that rubber boot off there, I'm going to disconnect the starter motor wire. I'm going to undo this bolt here. I'll just get a 10mm spanner or socket. Yeah, I can probably do it with a socket. Being careful, this is live here, permanent live at the moment with the battery in. So I'll just take the wire away. There we go. There's a little washer on here I'm just trying to get hold of. There it is. I can sit down in there safe. And I'm going to pull this 12 volt positive wire off the starter motor. So when I pull the OPC and push the start button, we should get an audible click out of the solenoid. Let's see. That first click is the OPC switch that we talked about earlier. Now when I push the button, the solenoid is indeed clicking. Okay, so that's good news. That means that the mechanical part of the solenoid, or the electromagnet, is working. So we know we have power to the solenoid. This said, we know we've got power coming out of the brown wire, the 12 volt when we push it. So we've got 12 volts positive going to the solenoid. We know we've got 12 volt negative because this is the black wire from the battery going onto the engine. If this solenoid is not clicking, we now know that we've got a faulty solenoid. But because it was clicking, we know this solenoid is okay. So the next thing to diagnose is, we know that the mechanical part of the switch, or the electrical part of the solenoid switch, is working. Now we need to test if we're getting continuity across the internal switch of it. So back to the multimeter. So again, I'll put my multimeter in there where I can see it. I'm just going to put a probe on that 12 volt. In fact, we'll use the red one. Put a probe on there. We need to touch the black lead, the other end, on the ground, which can be there. So now, if I, in fact, haven't got enough hands, let's see if I can get a ground somewhere else where I got a spare hand. Let's see where we can get to. That'll do. It's touching the body of the engine. that's touching the positive output from the solenoid. So I should get, let's put the meter where you can see it. Yeah, you can see it there. So now if I pull the OPC, push the start button, 12.1 volts. Now we have got a voltage drop there, but that is because the solenoid is consuming part of the voltage from the battery. So that's on, 12.05, off. This tells me that both functions now of that solenoid are working correctly. Okay, everything's correct as far until we get to the starter motor. Obviously, if I was getting something like 4 volts out of here, it would mean that the contacts in the solenoid were dirty and we would need to replace the solenoid. And again, much the same if I was getting no volts during that reading, would point me to a faulty solenoid. Now there's a little test I can do to see if the windings of the starter motor have broken completely. I should get, just with a simple beep test, between ground, so I'll touch on the body, and the terminal here, I should get a beep that tells me that I have got a continuous winding. I have. If I didn't get that beep, that would tell me that the starter motor winding has broken down and we've got open circuit. So that's a good sign. So I'll move on. I'll put the connection back on the starter motor. On with a little washer. Back on with the lock nut. Just pull that rubber boot out of the way. I'll just tighten that nut up again before I forget. Okay, just firmly down, only to go over the top there. Put its rubber boot back on. Okay, so if the starter motor is good, it should now start, or crank at least. I have removed the spark plug cap so the engine will not start. So I'm only going to pulse this. I'm going to pull the OPC. We can hear the click. When I push the start button, the engine turns over. Everything's working correctly. If nothing happened when I did that, that would tell me that I've got a faulty starter motor. Okay, so we haven't talked about this little switch other than it being for the OPC and it needing to be adjusted correctly. But moving on, what we've got is a negative wire from the engine coming onto this top pin here. And depending on which position the switch is in, is whether it outputs onto the lower or upper terminal. So just using a beep test, we can check the operation of this switch. So to test this switch properly, I need to remove this connector from the coil pack. So when a negative supply comes down this wire from the body with the switch in the right position, it will feed a negative supply onto this spark pack, which kills the spark. So I've just taken that connector off. So I'll just set my meter up for a beep test to just check. Okay, so I put my probe in this terminal, the negative probe in this terminal on the top, and I should get a beep there. Push the switch, gone. If I come on the top one, no beep, push the switch, and a beep. So depending on the position of the switch is whether negative comes from this top connector, out of the bottom or out of the top. Now the logic behind that is, when the switch isn't pushed, or when you release the OPC, it feeds a negative down this wire to kill the spark. I'll put that back on now. When you do pull the OPC, it feeds a negative down this cable, which transverses across the top of the engine and feeds a negative onto the starter solenoid. So that's why, unless the OPC is pulled, the starter solenoid won't work. So we need to check that we're getting negative coming out of that wire, which is the, oh, come on, yeah, the upper of these two, we need to check that when the OPC is pulled that we're getting negative out of there, which is a negative supply to the solenoid. Obviously if we aren't getting the negative out of here, it tells that electrically it's this switch that is at fault. Of course, another issue I've seen is that when you release the OPC lever, the engine doesn't stop. Again, it could be the switch at fault because negative isn't coming out of this bottom terminal, or it could simply be that this wire has come off the spark pack, or the spark coil pack, I should say. If this wire, which is the stop signal which kills the spark, has come off, then when you release the OPC lever, the engine would keep running. So that would normally be the point to suspect either the switch or this wire has come off. On the subject of spark, while we're in this area, if you find you've got no spark on the lawnmower, what I'd normally do is to pull that terminal off and then check for spark again. If you've still got no spark, I'd probably, obviously you'd change the spark plug would be the first thought, but you've got a new spark plug and no spark. I'd pull that off just to make sure we're not getting a negative out of there. We've still not got a spark, then chances are that it's going to be the coil pack that is faulty. Coil pack is very simple to change. You've got a bolt here which unbolts, another bolt here behind this air flag which unbolts, and the spark pack can be lifted away from the engine. To replace it, you put a new one on. I'd put 2 thicknesses of A4 paper between the flywheel and the pickups on the spark pack. Push the spark pack back into position with the bolts loose, then tighten the bolts, and then revolve the flywheel to get the piece of paper out, reconnect it all, and away to go. So that's how we would change the spark pack. Okay, so I think we've done all the diagnostics. I know everything's working. I'm going to put it all back together. Well, I do hope you found this demonstration useful. For more information on this or any of our other products, visit www.hyundaipowerproducts.co.uk. I've been Adrian, and thank you for watching.